Hey everyone, welcome back. In today's video, we are going to cover two important concepts that make your C++ code organized, efficient, and reusable: namespaces and inline functions. By the end of this video, you'll understand what namespaces are and why we use them, how to create and use namespaces, how inline functions improve performance, and when to use and avoid inline functions. And as always, we'll finish with a short mini project that uses both concepts together. A namespace is like a container that holds identifiers such as variables, functions, or classes to avoid name conflicts. Imagine two libraries having a function called print. Without namespaces, your compiler would not know which one to use. That's where namespaces come in. Here we created two namespaces, A and B, both having same function print but gives different result. We can access them using the scope resolution operator. If you don't want to keep writing A and then scope resolution operator, you can use using. So you will write using namespace A. You can then call it directly inside the main by just writing print function. But be careful if both A and B have a function with the same name. Just like in this case, we have same function print. The compiler will get confused. So it's better to write like this. Namespaces can be nested inside each other. Have a look at the following code. So inside the namespace outer, we have a namespace inner. To access the y element of inner, we have to write outer, then our scope resolution operator, inner, and scope resolution operator, and then y. Let's understand what an anonymous namespace is. An anonymous namespace means the code inside it can only be accessed in the current file. So this here is an anonymous namespace and we have accessed it here. This is useful when you want to hide implementation details in larger projects. So these are all the types of namespaces we covered. Now the question comes, what is an inline function? Normally when you call a function, the program jumps to that function's address, executes it, then comes back. This process takes a bit of extra time, known as call overhead. An inline function tells the compiler, instead of jumping, just insert the function's code directly where it's called. This makes execution faster, especially for small, frequently called functions. To define an inline function, we write inline, the data type, and then the name of the function. Inside the parentheses, we write our parameters and then write some lines of code. And inside the main, we simply called it. In the terminal, we will get sum 30 and sum 70. The compiler replaces each add a, b call with functions code directly, avoiding overhead. Let's create inline member function inside a class. So we created a class called math and then created our inline function. Functions defined inside a class are automatically considered inline. On the terminal we will get square 25. Inline functions are great for small, simple operations, but avoid them for long and complex functions with loop, recursion, or static variables. Otherwise, it may increase code size and slow down performance. Let's create a mini project math utility using namespace and inline functions. I was actually manually writing the program and then I forgot to record it. So let's just continue from here. So we just included our header and then wrote using namespace and created a namespace math utils. And inside it we declared two inline functions called add, which will add a number, and multiply, which will multiply a number. And then using display results, we displayed the results. Inside the main we called it and called our display result function. Let's see what we will get. So we got the sum as 12 and product as 35, as our numbers were 5 and 7. So this example shows here organized code using a namespace, fast execution using inline functions. So we use namespaces for structure and inline function for small codes. Great work! You just learned two essential concepts that make your C++ code clean, efficient, and modular: namespaces and inline functions. In the next video, we'll learn about preprocessor directives and macros, powerful way to control how your code is compiled. If you enjoyed this video, leave a like, comment #code with me to show your progress. Subscribe so you don't miss the next one. Thanks for watching, and as always, keep coding, keep learning.